go to your other classes?
Sorry?
Did you go to your other classes?
I had an essay due on Thursday, so I have to do it.
Yeah.
Other class.
You should have used copy.ai.
My girlfriend used it for like half of one of her papers.
Dude, I should get affiliated.
Yeah,
Just spreading them this, like,
When did you move to this desk?
Huh?
When did you move to much over there? I told you.
I was here the whole class jacket.
Wait, so how did you do? Generate it as?
I mean, she didn't like generate a whole essay.
Yeah,
She
but
generate like the intro and like a little bit of the thing, but
okay.
modified and added sources and like just kind of collaborative thing. Her class was, I think she just like created and everything. So she was fine.
Do another class just take.
I don't know which class it is.
Yeah.
I don't know. Is your life fine? How's your life fine?
Life, okay. It's okay. You missed out the part where I think I was talking because you weren't here on Tuesday. Oh, sorry, Thursday.
Thursday, yeah.
Yeah.
I watched the recording though.
Oh, okay, yeah.
I watched like the first 75% of the recording.
It's good enough.
Yeah.
Okay, let's wait for like a couple of, I don't know, 4 more minutes, I guess. Just randomly 4 more minutes.
Check how long it would take to become a competent smart contract engineer.
Competent?
Yeah, like I'm
Well, I'm 25, so it's gonna take 50 years.
No, you're God level. Like competent level.
Competent level?
Part of the conclusion there's no other path forward. Everyone else is.
You realize that?
There's just too much bullshit already.
Yeah, that's that.
But code doesn't lie.
Exactly. I've spoken to like a bunch of PMs over the past 4 weeks.
Yeah.
So many of them are just bullshit.
Dude, I still remember when you talked to Pinata's like, is it
They're full of shit.
Welcome.
Yeah, the engineers the only people.
You see, you asked that person where it hurts and they can't answer.
No, yeah, exactly. there's no way forward.
Huh? Yeah. We could do a few projects outside of class or something.
That would be awesome.
Yeah.
I appreciate it.
Like honestly, if anyone wants to work on something, work on some more advanced smart contract stuff that we don't cover in this class, but like if you're already like a programming god and you want to, because I know you are, right, Matt?
Oh,
Yeah. Yeah. If you're already a programming god, then we can do some more interesting exercises outside of class. I'll give you a prompt, you'll do it, and I'll review it.
Let's do it.
Yeah,
You're doing that after
Yeah.
class thing?
Well, you can unlock the prompt with a monthly payment of $100. You have to unlock the review separately.
You did the after class thing
Today, no, I have some meetings. I have a meeting and then an interview tonight, interviewing someone else, and then tomorrow 6 a.m. I have another interview with someone else.
What are your
What are you hiring for?
Huh?
What are you hiring for?
Like a team lead for like a separate team.
What are your main questions?
What do you do?
Huh?
How do you interrogate people?
How do I interrogate people?
Yeah.
I asked him, do you know Matthew Holloway?
Probably like
And if it's a no, then it's a no.
put her out. Yeah.
I try to ask him, I guess I'll just give him the problem and I want to see how they approach it. Because like at the level that I'm hiring, because I know I've seen their resumes are like decent, so I don't think I need to ask all of the technical stuff.
Okay.
So mainly like how they approach problems, how they manage teams.
Do you enjoy it?
And if they lick my boots, yeah.
How do you question.
Yeah. Like,
If you were asked that
how can you write a proof that proves 1 equals 0?
What's your ask?
No, you know the guy, I think was it the My Pillow guy? I think he had a book, and then the first chapter was like proving 1 + 1 = 1 or something.
Right. First stuff.
There's an actor that thinks that like 0 is equal to 1, but he's like serious.
Yeah.
I forget who it is.
Tom Cruise.
Yeah, something like that.
I think Tom Cruise. I think I've heard of it.
Ask him if you can pay him in $0 bills.
Well, the problem is there isn't any $0 bills.
Yeah, this one right here.
Okay. Enough chit chat. What's so funny?
Enunciate like
Hey, English is my third language now after solidity. Okay. Cut me some slack. Okay. Okay, so today we're going to talk about gas optimization. Who knows this guy? Oh, you can't really see this guy. Yeah, who's seen his videos?
What?
No. Jordan Peterson.
Oh, everyone.
I've seen his
yeah,
videos. Okay. I like it when he talked about that you have to clean a room.
Yeah.
I don't like it when he talks about climate change. Let's just leave it at that. Huh? He says climate change is a way for the elite to make poor people poor. Which
Kind of ouch.
you can see. Okay, I'm not saying it does. I'm not saying it's correct, but his logic is like they're pushing for electric cars, banning gas cars, but electric cars are so expensive now that poor people can't afford it, and then poor people can't afford cars. They can't go to work. They can't go to work. They're poor.
It's probably a lot more complex than that, right?
Huh?
Like, this sounds like an example, like oversimplified.
Yeah. Well, we all know. If you breathe in CO2, you get richer. Yeah. Okay, so a few tips, important tips when it comes to making our smart contracts run cheaper. Because again, you're not paying for it; your users are. And if your user has to pay $30 for a $10 swap, then they're obviously not going to use it, right? This was this screenshot is February 3rd, 2021. It's I forgot what was happening, but as you can see here, the gas fee was 3 ETH. Okay, so if you look here, wait, actually,
So when they were minting like land for one of those.
I don't know what's happening, but see, this guy, this guy. Wait, no, Olive is a girl, not Oliver.
Right, it's my soulmate.
Really? Okay, so Olive here, okay? It's a she, right? Yes. Olive, she's not even trying to do anything. She's trying to send herself 0 ETH, basically a useless transaction, okay? The gas fee is 3 ETH. Okay, isn't that funny? So the gas fee, you pay $5,000, right, to send yourself nothing. And remember, no one controls this. This is entirely supply and demand. Okay. I forgot what was happening. I think February 3rd. You know what? It could be when DYDX. I remember there was one time. If you guys have heard of DYDX, it's like a DeFi exchange or something. DEX, decentralized exchange. But basically, I think it was February. They were basically coming online, and people they were releasing their token, and then those who have used them before were able to claim airdrops. I'm not sure if this is the same time, but I remember the DYDX airdrop claim also paralyzed the entire network. Like the gas fees just went through the roof. Okay. Now, why is that? Why is this? Because when too many people are trying to use the network at the same time, it's like if you have like a garden hose, right? If you want to if more water wants to go through the little hose thing, then what are you? if more water wants to go through the hose, then it's more difficult. So the pressure actually goes up, right? Now, if water cannot be compressed, then there's no way for more people to more water to go through that hose opening. So the same thing here. So the network capacity is limited. You've got more people here, right? So so everyone wants to be the first to do what they do. So in the case of the airdrop claim, I don't know if they're trying to sell it or something, or like in the case of maybe the ape land or something. I think there was like a limited allocation and people were trying to get a piece of the land or something, right? Trying to buy one, mint one. So the network's over capacity. Everyone's trying to make their transaction get processed first. So it becomes a bidding war. And it just goes higher and higher. And on this screenshot, you can see that it's become frankly quite ridiculous. Okay. Now, moving to proof of stake does not solve anything. Okay, just saying. Moving to proof of stake does not make the network handle more throughput. What it does is it stabilizes the block times. It basically makes the network more stable because before you had a bunch of people trying to come up with a hash that meets the difficulty target, but now it's a set time, basically a set block time, and everyone and the validators, they all kind of take turns. It's all very nicely determined. There's no guessing. Okay, but that doesn't mean the network can run any faster, because the only way for the network to run faster is there are three ways. Okay, the first way is pretty much impossible in EVM. Is to enable parallel execution, which is just impossible. The second way, actually the first way also relies on the second and third way. So the second way is to decrease the block time. Case in point, Solana. The block time is in the milliseconds. But you can see what happens when your block time is basically equal to the network latency and then everything else that happens in your computer, okay? Your blockchain just runs into bugs and shuts down, okay? The third way is to increase the block size, okay? So that, sure, we're still doing 10 seconds per block, but for each block, we can fit more information into it, okay? So 3 ways to scale everything. We haven't done any of that, okay? So Ethereum, after moving to POS, no changes on performance, it's just more stable, okay? And also the energy footprint decreased drastically. And if you're a PC gamer, you can finally afford a graphics card that came out 2 years ago, okay? Although, of course, I got it first batch, okay? Okay, so nine different. Will layer 0 blockchains help scalability by storing some transaction data? I am not very well informed on layer 0 blockchains, so I am not understanding the question very well. I know Cosmos and Polkadot claim to be layer 0 chains. I'm not exactly sure how they work, to be honest, so I can't give a good answer on that. I am too ignorant to answer such a question, unfortunately. Okay, so 9 different things you have to watch out for if you want your contract to be usable by the users, more or less. All right, optimize for gas. Okay. Wait, is that 9 or 10? Okay, there's 9. First one, let's talk about something called storage variable packing. Okay. So as we said before, EVM works with 32-byte storage slots, okay? That's why we have bytes 32 and ITP-356, because they're both 32 bytes. They fit very nicely into an entire storage slot, okay? But you have to realize that different variable types, they actually have different sizes. So for example, uint8 obviously only occupies 1 byte, because 1 byte is 8 bits, right? 8 divided by 8 is 1. So we have Boolean here. Okay, Boolean is 1 byte. Why is that? Because Boolean is, as we said in uint8, and uint8 is the smallest uint, because at the very least you need 1 byte. That's the smallest unit. Okay, so Boolean is 1 byte. Bytes 1 to bytes 32 is really self-explanatory. I don't have to tell you. Okay, well, obviously, okay, so first, there's no bytes 1. It's usually, I think they change it to byte, singular. But obviously, bytes 1 is 1 byte, right? And we have address. Address is more interesting, okay? Address is 20 bytes. An address is I think it's a uint 160, okay, which is interesting. The uint 8, 1 byte because you divide it by 8, and then 16, 2, 32, 4, so on and so forth, all the way until 256, okay? And int and uint, it doesn't matter if it's int or uint. What matters is the number that comes after them that determines the size, okay? Now, have you ever packed a suitcase? No. Okay. Sounds like you're not a traveling salesman. Okay, only CS majors got that joke. Digital salesman. Okay. Okay. Who here has packed a suitcase? You can't tell me you've never packed. There we go. So when you pack a suitcase, now I'm not judging anyone. Do you just randomly toss things into your suitcase, or do you kind of fold them, trying to organize them? Organize? Are you just saying that because everyone else is here?
No.
Okay, so
Try to fit as much shit in there as possible.
Yeah, exactly. You organize so that you can fit as much shit as in there as possible. Okay, so it's the same idea with storage variable packing. Okay, imagine your smart contract storage as I wouldn't say infinitely large because there is like a size limit, but for the sake of simplicity, let's just say the store space in your Solidity smart contract is a suitcase that's infinitely big, okay? Well, but the thing is, the more space you take up, basically the more space that you waste. So what you're trying to do is just like the suitcase, okay? You're trying to pack as much shit as possible into as little of a space as possible, okay? So that's what storage variable packing does, okay? By arranging things in a certain way, you're able to fit more things into the same amount of storage slots, okay? So we have two ways of declaring variables and rather ordering them right here. So we have three uints, okay? A and C are uint 128s. B is uint 256. The only difference between line 1 or line 0, line 1 and line 2 are arrangements, okay? The order of the variables. Now, which one do you think is cheaper and why is that?
Lower.
Why?
Because you're packing two 128s into one storage unit, and the second one would be the first one. You would need 3 storage.
Bingo. Perfect. So the reason why the second one is cheaper is because, so for the first one, okay, so let's go back and remind ourselves, each storage slot is 32 bytes large, okay, or 256 bits, okay? So that's one slot. So for the first one, uint 128, well, that itself occupies half a slot, okay? But then you have uint 256. You can't squeeze a full slot into a half slot. So the uint 256 will be in its own slot. And then uint 128C comes around, but because it's after B, so it's another half slot, but it's located after B's slot. So what's happening is that you have a half slot that's between A and B that's wasted. You could have fit C in there, but you didn't. Okay, because you arranged them in a different way. Okay, it's kind of like, perfect example, Tetris. Okay, everyone here has played Tetris before, right? So in Tetris, what you're trying to do is you're trying to fit as many blocks, as many things as you can before. If you're playing multiplayer Tetris, that shit is intense. Okay, it's like it gets faster and faster for both player, and then you get like so frantic, you don't even have time to look at how the other guy's doing. But the goal is basically to pack blocks as densely as possible without leaving any empty space, because if you leave too much empty space, then you're a loser, and no one wants to be a loser, right? So if you don't want to be a loser, just save some gas for users, okay? By first step out of 9 is to pack variables like that, right? Kind of like when you're building Legos, you want to fit things as closely as possible. You want to leave gaps everywhere, okay? So now we have a visualization of this thing, okay? I can't even see. Yeah, so on the left side, okay, so we have a contract declaration, and then in there we have 3 public variables. We also have a struct, which I'll talk about in a bit, and we don't have to route this part, okay? This is why is this projector is so bad? Can you even read this? Boulevard, okay, that is horrible. So this is a visualization of how the slots work. Okay, so you see here I have bool declared first, which is a uint 8, which takes up 1 slot. Okay, sorry, not 1 slot, 1 byte. So 130 seconds, 30, whatever, 1/32 of a slot. Okay. Second one, uint, and remember, if it doesn't say anything, it's just ITP-356. Okay, by default, which I don't like. For some reason, I noticed Crypto Zombie makes you do that. Don't do that. Okay. Because obviously I'm more correct than Crypto Zombies. Okay, and we have bytes 4, which takes up well, it's 1/8 of a slot. Okay, so let's just visualize the first 3 variables here. Okay, the first bool, and by the way, this is not drawn to scale. Okay, this is 1/32, but obviously this is not 1/32. But this boulevard takes up just 1 byte out of the entire slot, which has 32 bytes, okay? But the second one, uint, takes up the whole slot, so it has to make a new slot now. So all of this space, which is 31/32 of a slot, okay? That's all wasted space, okay? And then you've got 4 bytes of bytes 4. That again, you have to make a new slot because, well, this is full and you can't add it back there because this is declared after uint, so it has to come after uint. So now you have wasted space. Okay. So the moral of the story is really just switch these 2 lines and you can save a single slot. Okay. And then when it comes to a struct, it's the same thing. Okay. So slots 3 to 5 represent how the struct thing is kind of structured, I guess. And you can see the same thing happening, okay? 2 uints within address in the middle, okay? The address takes up the middle slot, but then the uint 8, that's before and after the address, they again take up 2 more slots. Like this whole thing is just entirely unnecessary because you could have moved this here and then saved an entire slot, okay? Or even, because an address, well, I know it's a uint 160.
Wouldn't that only be 20 out of 32?
Yeah. So I'm not too sure. I forgot how addresses work. But the point is, for the other variables, you got to try to group the small ones together so that they can fit together into one. Okay. All right. So let's rearrange things a bit. Okay. Now this is the more efficient. Now this one is what I call, well, less efficient. What I call the naive approach. Okay. Because you're new. Well, this is the pro gamer approach. Okay. All we did was switch 2 lines. Just by switching 2 lines, look at the difference that it made in terms of how many slots we're using. Okay. You straight up save 2 more slots. Okay. So just by literally just declaring your things in a different order, you don't even have to, it's not even that much of an effort. You just have to keep the numbers in mind, right? You can save a lot of space, okay? All right, so that's the first thing that we have to talk about, okay? Yeah?
Is there a reason why there's no smart packing?
No smart packing? I don't know. No idea. I guess because the language earlies and the compiler doesn't do it for you. Yeah. Do they have that in C? Smart packing? I don't think so, because when I took game dev, C++, we have to do our own packing.
Oh, really?
Yeah.
Wow.
Okay, any questions so far regarding the slots and the sizes?
So is it just 32 bytes or 20 bytes?
I know for sure it's a UN 160 or 180 or 160.
So it's less than 32 bytes.
160. I'm not sure why on here it showed that it takes up a whole slot. I'm gonna guess that it doesn't. Yeah, I don't think it does because it's a UN 160. You can cast it back and forth, no problem. Yeah.
If you like really wanted to min max, say you wanted to store, could you store like the first like 10 bits of the address in just like slot 2, and then the other 10 in like slot 3 or whatever?
Yeah. Well, are you saying like you're breaking up data?
Yeah.
I'm sure it's doable with like inline assembly, which you can do, but then you have to decode it. Why would you do it? I think it's too much effort. Yeah. And just don't worry about what you just said. Okay. So now we have something called the 32-byte rule. Okay. So it is best to store data in types equal to or smaller than 32 bytes so that, it is best to store data in types.
So
I'm sorry, it's so, okay, exactly. So only a single read operation is triggered, okay? It's like the bucket analogy. It's like if you have you guys ever hauled water out of like a well? I'm sure it's everyone's, pastime, right? After you get lunch, you just haul some water up from a well in your backyard. I'm sure everyone does that. Okay. So it doesn't matter how much water you want. It's going to be one round trip, so you might as well get a whole bucket, right? So in Solidity, every single read operation, it pulls the entire slot. Okay. So if you're going to read it once, you might as well pack as much information in there as possible. Okay. So it just makes it so, like, for example here, okay? If I want to read both of these variables, with this arrangement, I only have to do the underlying read operation once from storage. Whereas over here, I have to do it twice because they're in two different slots. Okay. All right. Also, something to do with strings. If you're sure that the length of your string will be less than 32 characters, English characters, I think like Chinese characters take up more space. But if you're sure it's less than 32, then try to stick to bytes 32 instead of a string, because a string it's like a dynamic array and it's a bit more, you have to store a bit more data, but it's not that much of a difference, but there is a difference. Okay. Just know that it's something that you can optimize for. Okay.
How do you like substitute bytes 32 for a string then?
There's a way to encode and decode it in the front end framework, in the testing framework. I can show you guys in a bit. But once you convert it, it's no longer a plain text. You have to convert it back to like plain text. But it's lossless conversion, as long as you can fit all that into 32 bytes. If it's over, then you have to cut some information out.
Is that like common use, like just
To do that in your TypeScript?
To do
To
the
like do that conversion? To save gas?
It really just depends on, like, it saves a bit of gas, but it doesn't save. It saves some gas, but it doesn't. Wait, what is that? Anyone hear that?
DPS.
What is it?
DPS.
Oh,
EPS is here for you.
so you heard our chit chat. It saves a bit of gas, but not that much.
So like.
But it's still some gas that you can, like, if you're just trying to squeeze, you're trying to do like very aggressive optimization, you can do it. But also, like, if you're sure that it'll never go past 32 characters, then why not? Right? Yeah. Okay. All right. Any more questions so far? No more. Okay. Duplicate initialization. Okay. So, if a variable is intended to start off with a 0 value, then if you explicitly say something equals to 0, it's kind of a waste. Okay. It's not a waste of storage in that sense. It's a waste of execution gas. Because if you don't assign anything to it, what's the default value for everything in Solidity? 0, right? And if it's meant to be 0, and you declared it and you say, okay, I want it to be 0, so you do equals 0, it's just kind of pointless. Okay. I'm actually not sure if the compiler and optimizer will actually cache this. Okay, I'm not too sure, but just as a general rule of thumb, if it's going to be 0, just don't do equal to 0, because it's already 0. Okay, that's just one more step, one more unnecessary step. Okay. Constant values, right? If you are certain that this variable will never change its value, ever, okay? Meaning that it will stay constant forever. Then you can you can add the constant keyword. Basically, what adding the constant keyword will do is that when you're compiling the smart contract, the compiler will look at this variable and see that it's a constant. It will basically do a command or control F in your code and replace all instances of that variable with the actual number. Okay, so basically it's saving you a single storage space for this variable. Okay, so it's done by the compiler. Okay, if you have something that's not constant without the constant keyword, even if you never change it, it's still treated as a variable and written into storage, because written into contract storage because you never said it's constant. So it might change. Okay. Whereas if you set as constant, and when the compiler substitutes all occurrences of A with the number 7, that becomes a part of the logic. Okay. So that's where the savings come from. Okay. Yeah, so when you're using constant variables, the work will be done by the compiler off-chain before you deploy, so it's cheaper. Okay. All right. Operations on, okay, before this, any questions on these?
What if you're, oh, sorry.
Okay. Is it cheaper to like not even declare a variable at all? Like if you just replaced every A with 7.
It's the same thing as doing constant, because the compiler will do the replacement for you. The annoying thing with that is, what if you need to change the value of 7?
Yeah, I'm just asking if it's cheaper.
It's the same, because the compiler, when you're compiling, will do the substitution for you. Right? So there's no difference. Yeah. And constant variables, they're not a part of contract storage, because it's directly replaced in the logic. Yeah. In the contract code portion of the account storage. All right. Any other questions? Questions on this one? Relatively straightforward so far. Okay, it's about to get nutty, as they say.
What about like mappings and stuff? Those all fit into 32-bit?
No, mapping is different. Mapping is built in. Yeah. I'm not exactly sure how the storage works for that one. just treat it as its own thing. Just and that's why like when you see the code that a lot of people write, they usually group mapping separately together from the variables. They don't mix. They don't mix and match like a variable mapping, variable mapping. Okay, it's about to get weird. All right. You have to start doing math. Yikes. All right, operations on storage. Now, this is where all the majority of the gas fees, the gas usage comes from, okay? Reading and writing from storage. And also, fun fact, 90% of all software, computer science graduate jobs are basically some variant of reading and writing to a database, okay? Just glorified, right? Okay, storage operations. S-load and S-store. S obviously stands for storage. So loading and storing, they are expensive, okay? Loading, S-load, it reads a variable from storage. And the rules for that is as follows, okay? If this slot is accessed for the first time in this transaction, then it costs 2100, is it G way or way, I forgot. But of gas units, okay? But if it's already been pulled before, if the entire slot has already been pulled before, you only pay 100. So coming back to this one, if I were to read, if I want to read these two variables, okay, with this layout, I would have two different S loads on two different slots. So that would cost me 4,200 in gas. But with the next loadout, it's the same slot, so it's 2,100 plus 100, 2,200. So you can already see how much cheaper it gets if you arrange your things properly, okay? Now, as stored, writing it is more expensive, okay? So if you change it from a 0 to a non-zero value, okay, it is way more expensive than changing it from a non-zero to a non-zero value, because a 0 value implies there was nothing there, okay? So you're taking up new space, new empty space. Whereas if you're replacing a non-zero value, the space has already been used. You're just replacing the contents, okay? So it's cheaper. That's why it's cheaper. So and again, as stored, if that slot is accessed for the first time in that transaction, then it's 22,100. Else is 20,000. And notice how if it's accessed for the first time, it's basically a write and a read. See? But if you've already accessed it, then if you're just writing to it, then it's this. Okay? If you're changing from a non-zero to a non-zero, so you're just modifying the space that's already been used. So it's cheaper. If it's the first time, 5,000. Subsequently, 2,900. Okay? Okay.
The cost per slot, how many slot?
No. So this is for writing. So whenever you're modifying a variable, you have to. Okay, because the smallest storage unit is a slot.
Yeah.
So you can only read or write a whole slot. Yeah.
So these costs pertain to like a whole slot.
Yeah.
So regardless of if it's like half full or
Yeah, it doesn't.
full, the cost is the same.
I'm sure there are some more nuances when it comes to.
Like, what if you're changing a non-zero value, like that occupies half of a slot, to a non-zero value that occupies the
Yeah.
whole slot?
So I'm not sure because I haven't looked at. They mentioned it in their yellow paper, which is like full of math equations.
Is it yellow?
Huh? I don't know why is white paper, right? Why isn't it blue paper? Well, that's a blueprint actually. Yeah, but the point is, when you're reading and writing stuff from storage, try to make it so that basically try to optimize your storage layout when you're declaring variables so that when you're reading and writing, you read and write, you read from and write to as few slots as possible. Okay. Yeah.
Alright, I'll let you finish.
Okay. So let's see. Yeah, and also let's define what does it mean by access. Access for the first time. Okay. So access just means you've awakened that slot. Okay. So loading and storing both count as accessing. So if you loaded something before and then you write it, and when you write that, it's considered the slot is considered already accessed. Okay. Now the gas costs here, they can be all the gas costs related to like writing and reading. They've been changed before. Okay. There was a time where I forgot if I mentioned this. Basically, people were able to. So back then, writing to storage wasn't as expensive. So people were spamming transactions that wrote a bunch of stuff to storage. That's just doing like a lot of useless shit. And just kind of bloating up all the blocks and preventing others from normally using the blockchain. So they actually raised the cost afterwards, right? And all of these, like all the gas costs, that can be changed by the community through votes, through the Ethereum Foundation, and then if the miners, right now validators, if they decide to adopt it, they can upgrade the software. If not, they can fork or whatever. Okay, so all of these are adjustable. Nothing is like hard coded. Okay, and now there was something called the Berlin fork. That was like a trendy thing to talk about last year, I think, and that kind of got people excited, saying that ETH is going to become deflationary, whatever. So this information was after the Berlin fork. Okay. Oh, actually, sorry, no, that's not the Berlin fork. Berlin fork has something to do with the attack I talked about, not the deflationary, just a different fork. But basically, you see, that's what I said here. So they raised the initial read and write costs so that people can't spam blocks anymore. Okay. Okay. So the more recent change was how gas fees are calculated, I think, which we're not going to go over. Okay. So that was operations and storage. Basically, again, keep your storage tight, and then don't do unnecessary reads or writes. Okay.
Were the first set of optimizations just for contract, like the order you initialize variables and stuff?
Yes, but you see here, this is during execution.
Right.
So that also impacts this.
Right. So then, isn't it viable sometimes to not focus on like packing the smallest boxes, but packing the shit that you use the most and access the most together?
Yeah.
Okay.
Yeah. That too. Yeah. So a lot of different ways to optimize. Huh?
I was saying that's a good point.
Yeah. So a lot of ways to optimize for things. Okay. Okay. Any questions so far? Okay. Also, something we talked about. You remember if we talked about the denial of service attacks on arrays, like when the array becomes too big and then when you look through it, you'll blow the gas limit and you can't do anything. Okay. So here, due to the high cost of reading and writing from and to storage, if you don't know how big the array is and you do that, it's pretty bad. It gets bad very easily. Okay. So whenever possible, okay, try to not do that, basically. Okay. And if you have to work with arrays, you have to look at your logic and ask yourself, can this thing grow infinitely? Does it grow super quickly? How can I mitigate this problem where it gets out of hand and I can't do anything to it? Okay. And also, okay, don't ever save. It's just like how you don't write your the contents, like whatever you write on your scratch paper, you don't write it on your actual exam. Okay. So the intermediate values that you get through processing, don't save them to storage. save them to memory using memory variables. Basically, declare variables within functions or use a memory keyword because, okay, store costs 20,000 gas. store stands for memory store costs 3 gas. Okay, that is a pretty huge difference there. And that just shows you how much more expensive storage is compared to almost anything else. Okay. Okay, any questions so far? Now, you don't have to memorize the numbers. I won't test you on those, but you have to keep the principles in mind when you're writing code. Okay, I'm not gonna write a function, the transaction, and I tell you hand calculate the gas used for me. I'm not gonna do that. That's just idiotic. Okay, like you'll never do it in the real world, and like no sane person will ask you that question. Okay, but you have to understand the principles behind it and apply it to your code. Okay. Okay. So if storage is so expensive, but inevitably I have to store data, then what am I supposed to do? Right? How can I store data? Well, like I have to store data. You can't write a program that doesn't have any data persistence. Okay. You can't have a ledger where without writing anything to it. That's not a valid ledger, that's just an empty book, okay? Well, reading from and writing to storage, they're really expensive. But if the data that you're storing only needs to be retrieved externally in the future, but not from within the smart contract, you can store them in events, okay? So, for example, difference between the storage costs, like storing it in storage versus storing that in events. Okay, storing a uint result in store costs again. If it's non-zero to zero, 0 to non-zero, you get 22,000 gas. If you're updating a value 5,000, if you're storing it into an event and emitting the event, it only costs you 1,000. And again, the fundamental reason why is because events and storage variables, they are stored in different parts, fundamentally different parts of the blockchain. Okay, storage variables, they are stored under the account storage inside of your contract storage. Okay, but events is a part of the transaction receipt, which is stored in the transaction receipt tree. It's a totally different tree. Okay, so the the costs of storing things are different between those different sections. Okay. Now, the important thing about using events, sure, it's cheaper, but once it's emitted, it is no longer visible to any smart contract code in Solidity. You cannot retrieve the value of some event that you've emitted. Okay. It is only for front-end use. All right. There we go. There's call data versus memory. Okay. But before we do that, any questions on storing things in events?
The event emission cost doesn't change regardless of whether it's changing an existing value, non-zero value, or
There's no changing now. Each event emission is new.
okay.
Just like how past transactions cannot be modified. Because event is a part of the transaction receipt, that can't be modified either. Okay, some questions in chat. What do you mean by for front-end use only? Okay. What I mean is that, why is my computer so loud? What I mean is that once you emit an event, there's no way for you to retrieve the information that you've emitted within Solidity. Like for example, if you save some information to some variable, you can just call the variable again and you'll get the value back, right? But for an event, you just use the emit keyword and that's it. You emit it and it's gone. Okay, it's no longer inside of your contract. It's no longer reachable by the smart contract. Because a smart contract can only read data that's within the contract storage portion of the blockchain. But events are saved in the transaction receipt. It's something that Solidity fundamentally does not reach. Okay.
What would be a use case where it would be appropriate to use an event on contract storage?
Let's take a look at our good old friend Eaststein smart contract. Okay. Let's take a look. Okay, here. All right, here we are. So a quick reminder, okay? This is how I keep track of the contract, the PDF contract. This is getting confusing. The PDF contract within each signed signatures, okay? And this is the struct, and this is the mapping that contains it. Okay, it's a bytes32 pointed to a PDF contract object or struct. Okay, now, but you see here when people when the contract is created, a name is included in the event. Okay, the name is just a display name. Nowhere in the smart contract logic do I need to do anything to this name thing. So I don't have to access this at all. Storing it in contract storage is just wasting space because I never have to do anything with the name. The contract is identified by the contract ID, which is done through a bunch of hashing. Okay, so that's how I uniquely identify a PDF contract, not through its name, which is only for humans to read. Okay, so I don't really need to store this. But I need to make the front end know, like I need to make the front end aware of the fact that this name is associated with this contract ID. So I use an event to emit it. I don't save the name to the contract storage because I don't need to save it to storage and I save a bunch of gas. But at the same time, the front end will be able to get it because the front end can scan for it. Yeah.
But the contract ID is also stored to contract storage.
Well, the contract ID, it's not stored, it's a key in the mapping.
Okay.
So I don't store it. I only have to announce it, broadcast it to the front end so that they can retrieve whatever contract that's related to the ID. I don't need to keep track of a list of IDs.
Okay.
Yeah. Okay. So that's why you would use an event in this case. Yeah.
Let's say, is it about 1,000? Oh wait, never mind. It says store in a UN.
Yeah. So I'm sure it's a bit different for other types.
And how are the events retrieved, the emitted events retrieved again?
You use a front end framework to scan for it, or you use an indexing service to index it for you. Yeah. You usually use an indexing service because scanning is just not possible. It's too slow. No one can do it. This may be a stupid question, but how can the price of G-Way get very high during network overflow when it is just 1/billionth of the price of ETH? If G-Way is expensive, shouldn't that be proportional to the price of Ether? Yes, okay, but people can artificially say, this is what I'm supposed to pay, but in order to get my transaction before all the other people's, I will raise this price. Like I'm literally giving away money just so that you can prioritize me. Okay. So that's how it gets high. Think of it as you can think of it as just bribing the miners or validators. That's essentially what it is. If you're trying to get your transaction processed first, you're basically trying to bribe them to make it so that they process yours first. And of course, being a capitalist, right? They'll take whoever gives them the most bribes, and they'll accommodate those people first. Okay. It's like how first class always boards first and I always board last. You know? Okay, so that's how that's the case of like this is a case of where it's appropriate to store things inside of an event and never keep track of it anywhere else. Okay. And also, okay. Also, there's this thing. Metadata. Okay, so this I use, it's just in uint 8, but I use this number to represent if this PDF, like how it's encrypted. Now, how it's encrypted has nothing to do with the smart contract. All of that decryption, whatever is done off-chain, but the front end needs to know what type of encryption it's using, so that it can display different UI accordingly, and it has to do it in the fast way. It can't just parse through all of the files, download them, and then look through their stuff. It's too slow. Okay, this makes the front end work really quickly. It can display the UI instantly, and while also doing lazy loading. Lazy loading meaning that you don't load something until you need it. Okay. So again, this is just some like auxiliary data for the front end. This has nothing to do with the smart contract. But I'm just having it here so that it can be captured in an event and the front end can see it before I load anything. Okay.
Is that like encrypting the contract that's on Arweave?
Yeah.
So it's just, is it encrypted with their private key?
You see, well, this is going a bit off topic, but we have 3 different ways of encrypting things. The first one is you don't encrypt it. Okay. Second way is you can use your private key to generate a public encryption key. This is different from a public key and public address. A public encryption key used for encryption, and you can use that to encrypt something, and then the receiver can use their private key to decrypt it. So that's our second way of encryption. The third way is just the password generated AES key. You just have to know the passphrase to decrypt it. The second way is the safest, but it requires wallet support for the encrypt and decrypt calls, which currently I think not all wallets support that. MetaMask does. There's something called Web3 Auth they do. I don't think Coinbase Wallet does, and I don't think some of the other mobile wallets do either.
Did you guys handle that encryption, or did like you get someone on the front end to just
The what?
Did you handle that encryption, or did you have someone else on the front end deal with that?
It's in the front end logic. So the way it works is that okay, that's getting like too off topic.
Yeah, it's all good.
Yeah, I can talk about that. Also, okay, recipients added. Okay, we have an array of viewers. Nowhere in the signing process do you care about viewers. You only care about who's signing, who's signed, right? Viewer is purely like a front-end permission kind of thing. Like if you're not allowed to view it, then you're not allowed to view it. But smart contract doesn't know what a PDF is. It only knows about digital signatures. Okay, so this viewer thing is another example of how I'm only having it here to feed data to the front end. It doesn't have anything to do with the smart contracts. And saving this is very expensive because it's an address array. So I don't save it, I just emit it as an event. Okay. Oh my, I'm really tired.
Is there a max number of viewers?
I'm not sure what the max number of arrays that like the size of the array, I'm not too sure. But I know that for any event you can have up to 5 parameters. Yeah. Okay. Let's go back. Any other questions so far? I am like really falling asleep. Well, that's what happens when you get 3 hours. 4. I got 4. Why? Huh? Why? Well, the consequences of my own actions. I'm gonna stand up so I don't fall asleep. This is the first time you've seen a lecturer falling asleep in a class that he lectures. Okay, so now let's talk about. Well, I didn't.
Go home party.
Yeah, I had a party in VS Code where it keeps giving me errors. I fixed it this morning though, of course, as you would expect. call data versus memory, okay? So we briefly talked about it before, but I'm just gonna list it as bullet points, differences, okay? Call data, you cannot be changed. Memory, because memory is already a copy, you can actually modify the memory parameter directly, okay? Call data can only be used for function parameters, okay? Now, call data can only come from user input, but for internal functions, you could have call data as the data storage location in your parameter, but it has to be directly passed down from the user's call, from like an external function's call data parameter. Okay, any internal memory stuff you pass into a call data parameter, I'll tell you it's not going to work. Okay. Well, okay. Okay, this is not true. Let me change this. It is not a must. Okay. Yeah, I don't know why I said this here. So let me just delete this. So call data. Oh, okay. It's just poor English. I think what I meant was that only dynamic parameters of an external function can be used with call data. There we go. I have to change the wording. Only can and also call data is slightly cheaper than memory because you don't have to call, you don't copy it. Memory is already, when you declare something as memory as an input parameter, it copies the incoming, the original data. Okay.
Is that only dynamic parameters of an external function can be the call data type?
No, okay. So dynamic parameters of an external function can be either call data or memory. But call data can only be slapped on to a dynamic parameter of an external function.
Okay.
Or like if it's on an internal function, when you call the internal function, it has to be called within the external function to pass it down directly. You cannot pass a memory into a call data, but you could pass a call data into a memory. So here's the thing. Yeah. Okay. Last tip. You should enable something called an optimizer. Okay. So Solidity the compiler has a built-in optimizer. What it does is that it looks through your logic. It tries to simplify them whenever necessary, and they try to optimize it for different scenarios. Okay. So I can actually show you what it looks like. Okay, I can't show you this one because it's got a bunch of secrets. I can't show you this one either.
At some point during the semester, can we see the code for Flash row on smart program?
Yeah. Yeah. Now let me try to find something here. Huh? Okay, here. Okay. Optimizer, enabled true, runs 200. What does runs mean? Okay. So runs basically, it specifies, it's a stupid question, okay? This is the only stupid question that that's in this class. Okay. So runs kind of, you have to estimate how many times will this contract be called ever. Well then, how the fuck am I supposed to know how many times this contract will be called, right? Like, I don't know. I deploy this up there forever. I don't know how many times. But what it really indicates, it's a trade-off between deployment gas cost and runtime and further execution gas cost. Okay, so basically, the lower the runs number is, the cheaper the deployment will be, but the more expensive the actual calls after deployment, post deployment will be. Okay, but if you increase the runs number, it will increase your deployment cost, but decrease the subsequent run cost. So that's like the balance. The default is 200. I usually just leave it at 200. Having it is better than having nothing. Okay, because not having it is very easy for the compiler to warn you your smart contract is getting too big and getting oversized, and that we cannot deploy it to the mainnet because there is actually a size limit. But with the optimizer, you can usually reduce it down to below that threshold. Okay. Point is just enable it. Okay. There's no downside to enabling this. Right? Okay. Any questions so far on the things that we talked about?
So if it's generally like trying to reduce the code size, why is the deployment cost increased by having like larger run stuff?
So think of it like this. Imagine you're buying, okay, everyone here has bought IKEA furniture, right? I mean, otherwise, where do you buy yourself? Wayfair? Huh? AliExpress. Yeah. And then you find out your table legs are off to different lengths. So we've all bought things from IKEA, right? Or Amazon Basics. But for every single piece of furniture you buy, you have to assemble it yourself, right? And it comes with like this manual thing with the guy with the deformed mouth, you know. But the point is, okay, so you can think of the user manual as how the optimizer might work. Okay, if you make the instructions super detailed, the users will have an easier time assembling the furniture, but you'll have to print more pages because you have more instructions. But, well, that's like more deploy cost, but less runtime cost. But if you just have one page and on it you just write do it, or user intuition, which is fun. I hate it so much when professors say that. Like, if I had intuition, it wouldn't be here. But like, if it only has one page that says use intuition, and that's it. Sure, the deployment cost is very low, but then the users, they have to work really hard to accomplish the same thing. So you can think of, it doesn't work exactly that way, but it's a good way to think about it. Yeah. So why having lower, like how does it increase deployment costs but lower further subsequent runtime costs? Yeah. All right, any questions on the things that we talked about today so far? All 9 of them, yeah.
What is the range of the runs that you can input for the?
I think it can go up to like the thousands. I'm not sure. I've never.
Plenty of smart contracts obviously get called like millions of times.
Yeah, but like it's a misleading name. They shouldn't name it runs. It should be named. It's basically imagine it as like a slider that you drag between 2 ends. Okay. Runs is a poor name, but again, we're talking about engineers naming names here. So. But usually just leave it at the default 200, it's okay. Yeah. I mean, okay. You should spend more time optimizing your logic than obsessing over which number to use. Not saying like the numbers aren't important, but I'm just saying like for the same amount of time that you spent, you can spend it elsewhere better. Yeah. What's going on, man? Is it the RSV?
July weekend.
So you know Orange County, we've declared like a health emergency because
In OC?
food- Yeah, OC, yeah, which is why I'm here.
I was
Why?
I'm giving it to everyone.
I was just looking for
Flu?
RSV. I don't know
Because
what's-
RSV.
Now we're going off topic again.
Monkeypox variant?
Uh, I can't pronounce this, but it's a common respiratory virus. I can't pronounce it. Okay,
Respiratory sinusitis virus.
sinusitis. There we go. Yeah. Sinusitis. So soylent. Any questions on what we talked about today so far?
Go back to the events slide.
Events, okay.
How will we get like kind of tested on this? Or like how will you test our knowledge? Is it like you're gonna give us an inefficient code and we have to find how we can make it
That's a
efficient?
good idea. I haven't thought of that.
It's not really good.
It is a good idea. Maybe I should do that for the final. And of course, you can't
just
you-
enable the optimizer.
That's not a valid answer, I'll say. Yeah, that's a good one. Yeah, I should. Yeah, I really should.
Grade us relative to each other's gas emissions.
No, I should.
Actually, that's better. I think that's better because like
Because everyone can just collude and have the same gas usage.
That's true. How would we do that?
Or maybe this. Okay. That the score of that question is going to be like a bell curve,
Yeah.
score distribution, and and it's all relative. So whoever has like the lowest gas will be at the top. Right. Yeah. You know, in CS-356, we had an assignment where we have to optimize a piece of C code to make it not only run under a certain memory usage, but also under a certain time. Yeah, and they gave us a score.
Wait, which class is that?
356 computer, like architectures. So that's fun. That could be fun, but it requires a bit of effort, which is difficult to give when you have 4 hours sleep. Okay, any questions on events for you here? Daniel? No questions?
I just wanted to see it again.
Okay. Okay, any other questions? No more questions so far? Okay, so if we don't have any more questions, let's do something here, okay? Let me do this. Give me a second. Let's do something fun. All right, I'm going to show everyone homework 5. We'll go through it. Okay? And then I'll post it tonight or depending on when I go to sleep and everything. Okay, let's take a look here. Let me actually put this up on Notion. Okay, it's called TypeScript testing. Okay, so in homework 5, well, you but, okay, if you don't want to, you don't have to write any Solidity code, because I have it for you. A pristine magnificent piece of Solidity source code for you, okay? But here's what you have to do.
Just on Notion, right?
Yeah. So here's a joke on the cover. Let's see. There we go. A QA engineer walks into a bar, orders a beer, orders 0 beers, orders 9 beers, orders a lizard, orders -1 beers, orders something random. The first real customer walks in and asks where the bathroom is. The bar bursts into flames, killing everyone. Okay. So the point is, even if you are a pro QA engineer, customers will always pull some shit that you've never thought of. Okay. Your users are always your worst enemies. Okay. All right. So TypeScript testing. I wrote this platform that's totally original called Come Fund Me. Okay. Never took inspiration from anyone. It's a fundraising platform on Ethereum. Okay. Anyone can start a new campaign. Other people can donate to it. Once the funds are donated, they cannot be refunded because remember when you were younger? I mean, at least in China, after the checkout, after like the cashiers checkout lines or whatever, there's always this like glass box, or not really glass, like plastic, plexiglass. I don't know. It says like Red Cross donation box, and there's always like a bunch of paper pills in it. I've always fantasized about getting like a wire or something into it and fishing all the bills out. Everyone's had that thought if you've seen one, I'm sure. No? Because you've never seen one.
It's not that much money in there though.
Huh?
It's not that much money in the Red Cross donation.
Okay, rich boy. Anyhow, so the money that you donate, you don't say like, I changed my mind and want a refund, because the point of donating is so that there's no return policy. You donate it, right? So anyone can start a campaign. People can donate to it. The donated funds cannot be refunded, and the initiator of the campaign can end it and collect the raised funds at any time. Okay, so that's the general gist of this thing. Your first task is you will have to deploy it to Kovan. Well, okay, I have to change it because we no longer have Kovan. We have Goerli. O with the 2 dots. Goerli. Test that. Okay, I'll have to change that. There you go. I'm a pro here. Goerli. There we go. There we go. Deploy onto Goerli and verify it, and I'll go over how to do that on Thursday. Okay, and also you have to link it to the README, and the TAs will grade it. Okay, we'll look at it if it's actually verified. So you have to deploy it and you have to verify it, both of which we'll go over on Thursday. Okay, and then we have to create a new TypeScript file, and then basically bootstrap it, meaning that like you prepare yourself to write the test cases. Okay. And then I've got 2% for unit tests and 3% for functional. I might change this, okay? But the point is you have to write some test cases, and they cannot be trivial, okay? But you have to write some test cases to test the code, okay, to see if it works correctly, right? And I'm actually going to change it this time, today, tomorrow. I'm gonna differentiate between unit tests and functional tests. That's just kind of confusing, okay? But at least, okay, you need at least 1 test. So I'm thinking you need at least 4 test cases, but 2 of them, at least 1, you have to walk through the process as if you're a normal user. And the second one, you should try to do things wrong at every single step and see how the smart contract reacts, okay? Because that's how you're supposed to test code. You should make everything go wrong as much as possible and see how your smart contract reacts. Okay. Extra credit. 3% to your grade, my friends. All right? A full 3% to your actual grade. First part, I want you to extend some functionality for come fund me. Okay? And you should basically create a new file, name it come fund me v2. Okay? Also rename the smart contract to be like that, to add v2 to the contract name. Otherwise, your test cases can't run. Okay. You have to add a few functionalities. First one, when someone is starting a campaign, they have to add a campaign deadline. Okay. Meaning that I think so any funds donated before deadline can be withdrawn before deadline. No funds can be donated after a deadline, and the initiator cannot prematurely end it. Meaning that if you've donated, as long as the deadline hasn't hit yet, you can request a refund. Basically, you can get your money back. After the deadline, no one can donate anything anymore. The campaign becomes read-only, okay? And the initiator can only withdraw the money after the deadline hits, and the initiator cannot withdraw money before deadline hits. Okay. And then 1% you have to write again 2 tests. One running through everything normally, and the other one you have to do every single thing wrong at every single step. Okay. Imagine basically you have to make everything go wrong to see if your smart contract correctly stops the user from doing things that they shouldn't be doing. Okay. All right. Any questions so far? So for the testing part, don't worry. Okay. So the deployment verifying and the testing part, we're gonna do some of it on Thursday. Okay. We'll do it in class together. And let me actually make homework 5 right now, so you guys can get started. Maybe can take a look at least. Okay.
For the bug hunter, like, are there any bugs or is that just like a wild goose chase?
Just for this assignment, if you can find any bugs, then come fund me, and if you tell me, I'll give you 0.5%. For each new bug you find, 0.5. If you can find me 200 bugs, you get 100% in the class, guaranteed. If you just fail everything else, okay? Unless you cheat, which I can't. But if you somehow can find 200 bugs, I'll give you 100%. Okay.
And that's just on the original contract.
Yeah, I mean obviously your own contract will be full of bugs. Okay. When I wrote "come fund me," it was 2 a.m. Okay. And because you guys are writing the test scripts, I didn't test my own code. So it was just.
Well, you didn't test it at all.
No.
You tested it a little bit.
I compiled. That's it. So if you find a bug, then and it is likely that you'll find one, then the first person to come to me with that bug will get 0.5% added. Okay.
So it's also a race. So like nobody can. Nobody
yeah.
can. There can only be one bug per person.
All 5.
You can have as many bugs as you can, but if someone else has reported your bug, then it doesn't count for you.
Okay.
You don't even get an uncle reward, armor reward. I'm sorry, I have to use the correct term.
So we can't like work together.
Huh?
So the class can't work together to find 200.
Well, you can work together, but game theory, if your teammate betrays you and comes to me first and you get left with nothing, how would you feel about that? Or maybe you'll be the snake instead. Yeah? But if you don't find any bugs, then you just know how good I am at writing smart. Okay.
So the TAs manually create our test scripts, or do you have a test script to test scripts?
No, but so we'll look at your test script to see if they're trivial, to see if they're meaningful. I mean, there are only so many ways to test things. So, yeah, but there sadly there isn't a test script tester. Yeah. Okay, let me do something here. Let me publish homework 5 real quick. Sorry. Verification, which is of course not showing up. Well, in the meantime, the market kind of pumped. So,
I thought it was going down to 700.
huh?
I thought ETH was going to 700.
Yeah, it will.
Still will.
Right after you sell. Or right after you buy, I'm sorry. That's exactly what's going to happen. Okay, let's see. Come fund me. All right. Okay, so let me release this homework real quick.
We use Alchemy to deploy.
Now you're going to write your own deployment scripts. It's a whole other can of worms that we're going to open up on Thursday.
What gateway will we use?
They're free official gateways that you can use. Yeah. Or I can give you my free tier gateway. Just don't. Well, you can't really do anything to use it. Okay, so for homework 5, I don't have a deadline in mind right now. I'm just gonna post it, and we'll see like how we progress. Okay. Okay, let me share the link right now on Notion. Okay, link's been updated. You guys can take a look at the contract. Let's actually take a look at the smart contract together, shall we? Yes, that's not a question. Let's see. Come fund me. Once again, I'm asking for your financial support.
Just that guy trying to GoFundMe for Mark Zuckerberg.
Why?
Because like his net worth went down by $100 million.
I feel bad. I think he's doing the right thing.
So,
I'm a Zuck fan.
no, it's funny.
Zucker.
I don't think it was anti-Zuckerberg. It was just
Yeah,
funny.
it's funny. Yeah.
Mark needs our help.
He's a lizard.
Huh?
He's a lizard.
Well,
Did you see the
what?
interview?
Are you a
They made him
lizard
do a
too?
captcha first and then started.
Like stream. Yeah. Can you? Yeah, that was funny. Okay. Let's talk about this. Okay. Come fund me. This is the smart contract. Okay. So first we said again, anyone can start a campaign. Others can donate to the campaign. There are no refunds, at least not in like the base version. We're not talking about extra credit. And then the initiator can end the campaign at any time and then withdraw the funds. Okay. So we have a struct called campaign. Okay. And
Did you make the homework available now? Yeah.
oh, I have to share it.
How exactly does the
Refresh.
importing of the book and stuff work? That's just like,
Okay, we're good.
sorry.
How does it work?
Yeah.
I'll show you later. Yeah, I'll show you next time. I'll show you when we're working on homework 6. Okay. Come fund me. I have a struct called campaign. Okay. It's got a few properties. Boolean to indicate if this campaign has ended or not. An address, who the initiator is, how much funds are raised, and this campaign can have like a title and description. Now, obviously, title and description, they shouldn't be saved on chain because it doesn't matter, but we're not really worrying, like this is just an exercise. We don't care about gas fees, gas costs, so this is okay. Okay. And we have a mapping that maps from advice 32, which is the campaign ID, to an actual campaign struct. Okay. Private campaigns. Okay. We've got 3 events: campaign started, ended, and donation received. Okay. So, and obviously they come when the campaign starts, when this initiated, this event is emitted. When the campaign is ended by the initiator, this one's emitted, and when anyone donates to that campaign, this one is emitted. Okay. So we have the usual things from the midterm and the previous homework assignments. Okay. Start campaign. Okay. And I have all the documentation here. Okay. What does this function do? And description, whatever. Okay. So start campaign basically just creates a new campaign. That's it. But it checks if there is a campaign that already has the same ID. Okay. Or if basically it checks if there is another campaign with the same ID that's already ongoing. Okay. If so, then you can't. You have to change your campaign ID. And campaign ID is obtained through hashing the initiator and the title and the description. Okay. I do it internally like that. Yeah.
Is there a reason why the require statement?
Because I won't know if, like, I have to get the ID first before I can know if this ID is occupied. Yeah. Okay. And at the very end, this event was emitted. Okay. And this just ends the campaign. Okay. It checks if the sender is the initiator of the campaign. If not, then you can't just randomly end someone else's campaign. And also, we have to check if this campaign is still alive or not. If it's already ended, then you can't end it again. Okay. And also, we're basically transferring all the funds that have been collected, donated to the initiator. Okay. And then we emit this event, campaign ended. Okay. Donate to campaign. You're just sending money, so it's payable, meaning that you can send money alongside the function call. You're just sending money over here, and then increasing the total amount of funds raised. And also the reason why you can't do refunds in this version is because we don't track. We don't really have a way of tracking who donated how much. Of course, we see it through the events, but there's no way for us to know it in Solidity. That's the problem. And get campaign just returns a campaign struct object. And also get campaign ID can help you generate the campaign IDs using these information. Okay, so that's a smart contract. You guys can take a look at it. Before Thursday, and Thursday we'll just come in. I'll assume everyone's familiar with the smart contract. We'll learn how to deploy it, verify it, and then we're going to write a few test cases, okay? Together, and then you'll write the rest on your own, okay? So last semester, homework 5, we basically wrote half of the test cases together in class, actually my mood right now, but I can't because I'm lecturing. I'm actually okay, any questions so far on homework 5?
Why is it necessary to deploy it first before writing the test case?
To do what?
To deploy it first.
No, it's not.
It's not necessary.
You should do test cases first, make sure there are no bugs, and then deploy.
So why exactly are we deploying it?
I just wanted to get it over with.
Or just like the process of deploying it?
That's not the actual workflow. You have to write all your test cases and everything before you even think about deploying.
Don't you have to deploy it to like a test net to test
When
it?
you run test cases, the local environment, the tools that we're using to do that for you. Every time you run the test case, it spins up a fake blockchain, and then when the test case is finished, it deletes it or resets it rather.
So if you know how to do TypeScripts or test your contract on TypeScript, do you still need to use a testnet? Like, why would you want to use it then?
Okay, so you can also test things that are on live blockchain networks through TypeScript. That's fine. It's just that by default, if you don't specify anything, it's testing on the local fake network. And the reason why you want to test on a testnet is that in the real world, there is something called block time. So there's actually latency. But when you're on the fake blockchain, everything happens instantaneously. So some bugs only show themselves when you have this latency going on. Especially like later on when you're doing front end stuff. Like you have to implement like a waiting screen or a spinner or something because like the very first rookie mistake I made was that I totally forgot about the fact that we have block times in the real world. Yeah. So the web page it wasn't prepared for that. So using testnet's fake money, it's a pretty good mirror of the real network, of the real shit. Yeah. It's a good way to, so basically you want to write test scripts to make your contract run flawlessly on the local fake network, and then you deploy onto the testnet to test everything again, and if that works fine, then you deploy it to the actual mainnet for production. Yeah.
Is there a reason why you put a contract like this on Ethereum rather than Polygon or vice versa?
No, Ethereum is like the OG, so we're using it. But when we're deploying on testnet, so it's fake money. Polygon is cheaper. All right. Any questions? I know you don't.
Super coder.
Huh?
It's already
Yeah. Copywriter. Okay, I don't have anything else. We'll end the class here. If you have any questions, you can come talk to me. Otherwise, I'll see you on Thursday. And if you want help on Thursday, if you want to walk through everything, if you want points on the homework, come to class on Thursday so we can do everything in class together. Because if your thing doesn't work on Zoom, then it's hard for me to debug it for you. If you come over, I can just walk to your seat and tell you that you have to. I can't say that because I'm recording.
You can use remote control on Zoom.
Yeah, but it doesn't work half the time, and then for older versions of macOS, you have to restart Zoom, and it's really annoying.
TeamViewer?
I was betrayed by TeamViewer. You know that? They used to be so good, and they totally went down the drain.
Not really. Avid TeamViewer user.
You?